All right, let's talk about the man whose name is basically a synonym for genius, Albert Einstein.
Yeah, we all know the face, right? The wild hair, the famous photo with his tongue out, but let's go deeper than that. We're going to dive into the three revolutionary sets of ideas that didn't just tweak science, they completely rewrote the rules of reality itself.
But to really get a grip on this revolution, you have to meet the revolutionary. And honestly, he was a pretty unlikely genius.
I mean, if you looked at his early years, you would never guess what was coming. He was slow to talk, he hated the rigid, learn-this-by-heart style of his school, and when he graduated, couldn't even land a teaching gig? He ends up in this quiet job as a patent examiner, which, it turns out, was the best thing that could have happened. It gave him something way more valuable than a fancy title. It gave him time to just think.
And boy, did he think. So, while his day job was looking at inventions for things like gravel sorters, no joke, he was running these incredible thought experiments in his head. And these weren't just idle daydreams, they were about to lead to the single most productive year of his entire life.
So get this, it's 1905, the year scientists now call his annus mirabilis, his miracle year. This completely unknown patent clerk publishes 4 papers, 4, in a single journal. And any one of them would have been enough to make him a legend. Okay, paper number 1. He tackles this thing called Brownian motion. You know, that random jittery dance the tiny particles do in a liquid? Well, by explaining that, he gave us the first real hard mathematical proof that atoms and molecules weren't just some useful theory. Nope, they were real. Then he moves on to the photoelectric effect. And this is where he drops a truly wild idea. He says, hey, light isn't just a wave like everyone thinks. Sometimes it acts like a tiny particle, a little packet of energy he called a quantum. This was so out there, but it was the idea that would eventually win him the Nobel Prize.
And then came the big one, special relativity. This paper just completely took Isaac Newton's physics, which had ruled for centuries, and turned it on its head. He said space and time, they aren't absolute. They're relative. They can stretch and shrink depending on how fast you're moving. The only thing that's always the same for everyone? The speed of light.
And as if that wasn't enough, he adds this little, like a postscript to that paper. And in it, he casually drops the most famous equation in the world, E equals mc squared. It's so simple, but it showed that mass is just a super concentrated form of energy. He basically unlocked the secret that powers the stars and eventually the atom.
Okay, so you'd think he'd take a break, right? Nope. Einstein knew there was a huge piece of the puzzle missing. Special relativity was amazing, but it had nothing to say about the one force we all feel every single second, gravity. For more than 2 centuries, everyone just went along with Newton's idea. Gravity was this invisible force, like a rope pulling things together. It worked, but nobody knew why. Einstein's idea was, well, it was something else entirely. Way stranger, and frankly, way more beautiful.
So, in his general theory of relativity, which he finished up in 1915, he said gravity isn't a force at all, it's just geometry. Think of space-time as a giant rubber sheet. If you put a heavy bowling ball, like the sun, in the middle, it creates a dip, a curve. And a smaller marble, like the Earth, rolling nearby isn't being pulled by the bowling ball, it's just following the curve in the sheet. That's gravity. Now, the cool thing about this wild idea is that it made a prediction you could actually test. It said that starlight passing by the sun should get bent by that curve in space-time. So, in 1919, during a solar eclipse, astronomers checked. And guess what? The starlight bent by the exact amount he had calculated. It was a perfect match. And just like that, overnight, Einstein went from being a respected scientist to a global superstar. Okay, so warped space-time, packets of energy, this all sounds incredibly abstract, right? Like stuff for dusty chalkboards. But what does it have to do with our actual everyday lives? Turns out, pretty much everything. Let's go back to that Nobel Prize-winning paper for a second. The one where he said light acts like a particle, a photon. Well, that's it. That's the core principle that makes a solar panel work, turning sunlight into electricity. It's also exactly how the sensor in your phone's camera captures a picture. So much of our modern electronics really starts right there. All right, and what about the really weird stuff? His theories of time and space being all warped and relative sounds like science fiction, right?
Well, there's a good chance you used it on your commute this morning.
See, your phone's GPS relies on signals from satellites whizzing around the Earth. But because those satellites are moving so fast, and because they're in a weaker gravitational field, their clocks literally tick a tiny bit faster than ours down here. If we didn't use Einstein's theories of relativity to constantly correct for that difference, your GPS would be off by miles every single day.
But here's the thing about Einstein. His influence went way beyond the lab. Once he had this incredible fame, he used it to become a really powerful, and yes, sometimes controversial, voice on the world stage.
He was a lifelong pacifist who had to flee Nazi Germany himself. He became a passionate advocate for peace. He was a very vocal supporter of the civil rights movement here in America, and he constantly pushed for nuclear disarmament.
And this is where you see just how complex he was. He wrote this famous letter to President Roosevelt, warning him that the Germans might be building an atomic bomb. And that letter helped get the Manhattan Project started. But he came to regret that role so deeply. He spent the rest of his life warning the world about the very dangers he had, in a way, helped to create.
You know, Einstein's quest never really ended. He spent the last decades of his life searching for a single, elegant theory that could unite all the forces of nature, a search that physicists are still on today. And maybe that's his real legacy. It's a powerful reminder that the universe is just packed with mysteries, and that the most important thing we can possibly do is to never, ever stop questioning.